Let us solve a question on price elasticity. This question was asked by a brother on Telegram channel of Economics. The question is like this. Mary's demand curve for food is being given by Q is equal to 10 minus 2P. Q is the quantity of food and P denotes the price of the food. Her, okay, sorry for this mistake. Her price elasticity of demand for food at equilibrium price is being given as minus 2 upon 3. We have to find out that very price. Okay, the options are 2, 4, 1, none, 10, 10 or 10. Now let us see how to solve this. We are being given the demand function Q is equal to 10 minus 2P. This is our demand function. We are also being given the elasticity of demand. Let me denote it by like this. Price elasticity of demand at equilibrium price is equal to minus 2 upon 3, and we need to find out that very price. Okay, so we have to find out. So what is the formula for finding out the price elasticity of demand? So we know elasticity of demand is being given by, let me write it like by like this notation. So elasticity of demand is simply uh, dq upon dp into p upon q. Okay, so this is the usual price elasticity of demand formula. Now elasticity of demand is equal to minus 2 upon 3. So in place of this elasticity of demand, I can write minus 2 upon 3 should be equal to, I need to find out this dq upon dp. What is dq upon dp? dq upon dp means we need to take the derivative of this demand function with respect to price. Okay, so the derivative of a constant is equal to 0. How it is? So let me also show it here. If I say the derivative of this constant is equal to 0, so what I mean by this, let us say we have a function y is equal to x to the power 5. So its derivative, that means dy upon dx, is equal to, by power function rule, this power will become coefficient into x to the power, this exponent will be subtracted by 1. So 5 minus 1, this is 5x to the power 4. Okay, so the derivative of this function comes out to be this. Okay, now if we have only, let us say we have y is equal to, let us say, any arbitrary number 5. Okay, in this case I can write it like this: 5 this x to the power 0. Okay, x to the power 0 is equal to 1. So 5 into 1 is 5. So we didn't do anything with this. These two things are present same. Now using power function rule, dy upon dx. Okay, what does the power function rule tell us? If we have x to the power n, its derivative is simply n becomes coefficient x and n is subtracted by 1, using that very stuff here. So this 0 becomes coefficient, it will be multiplied with 5, then we have x to the power 0 minus 1. So this is 0 times anything will be equal to 0. That is how the derivative of a constant is always 0. Okay, so pata गैसे आसिन hey. So when I told you dq upon dp, I mean the derivative of this function with respect to price. Derivative of constant is 0, so we are left with this minus 2p. Derivative of p will be 1 by power function rule, so we are left with only minus 2. Okay, so in place of dq upon dp, I can write minus 2 into p upon and q, which is being given us as 10 minus 2p. Okay, I hope I am making myself clear. Now doing some, I can cancel these two, but I will obviously transpose this here, or I can simply cancel these two, or let me write it like this: minus 2 upon 3. Okay, if I transpose, it will become 1 upon minus 2, then you can cancel. Or we have p upon 10 minus 2p. Okay, so we are left with only here 1 upon 3 should be equal to p upon 10 minus 2p. So cross multiplying, so we have 10 minus 2p should be equal to 3p. So we have 10 is equal to 3p. Transposing this minus 2p, it will become plus 2p here. So 10 is equal to 5p, which means 5p is equal to 10, which means our p will be equal to 10 upon 5, which gives us p is equal to 5 ones are 5 twos are. So our equilibrium price will be equal to 2. I hope I make myself clear in this video. Thank you. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.